In 2009, Usain Bolt did something that shocked the world. He ran the 100-meter sprint in 9.58 seconds, reaching a peak speed of 27.78 miles per hour. Nearly 2 decades later, no human being has come close to touching it. But biophysicists say Bolt didn't just break a world record. He ran straight into a literal wall built by human evolution, a boundary hardwired into our DNA. This is the exact science of why the human machine has a strict, unbreakable speed limit, and the terrifying things that would happen to your body if you tried to cross it. To understand what stops us from going faster, we have to look at the work of Dr. Peter Weyand from the Locomotor Performance Laboratory. For decades, the consensus was that human speed was limited by how fast we could swing our legs through the air. Dr. Weyand proved that theory entirely wrong. When an elite sprinter is at top speed, their foot is in contact with the track for less than 1/10 of a second, roughly 80 to 90 milliseconds. In that blink of an eye, the athlete must strike the ground with a force up to 5 times their own body weight. Running fast isn't about moving your legs quickly in the air. It's about how violently you can smash your foot into the earth to launch yourself forward. Right here is our first structural bottleneck, our internal architecture. Dr. Weyand's laboratory testing discovered that human muscle fibers are theoretically strong enough to push a human to 35 or even 40 miles per hour. But our infrastructure cannot survive it. If a human attempted to push off the ground with the force required to hit those speeds, the mechanical load would instantly snap the Achilles tendon like a rubber band and cause stress fractures straight through the human femur. Evolution built our bones to handle gravity, not the physics of a sports car. If the bones are the frame, the muscles are the engine. But humans are running on the wrong fuel mixture for raw speed. Skeletal muscles are comprised of 2 main types of fibers: slow twitch, built for long-term oxygen efficiency, and fast twitch, built for explosive, immediate power. A cheetah's muscle profile is an absolute evolutionary marvel, featuring over 70% super-fast twitch fibers that allow them to accelerate to 60 miles per hour in seconds. The average human, however, is stuck at a conservative 50-50 split. Even elite Olympic sprinters, who are genetic anomalies born for the track, top out at around 60 to 65% fast-twitch composition. Why didn't we evolve to have more? Because of a biological trade-off known as persistence hunting. Millions of years ago on the African savanna, early humans didn't survive by outsprinting prey. We survived by tracking it for hours, sweating efficiently, and running until the animal collapsed from heat exhaustion. We traded raw, explosive velocity for ultimate endurance. To give humans more speed would mean erasing the exact evolutionary trait that kept our species alive. So when you factor in the limits of our tendons, the constraints of our muscle fiber ratios, and the milliseconds our feet spend on the ground, what is the absolute mathematical ceiling for the human species? Biomechanical simulation models have attempted to calculate a perfect human run. They programmed a digital simulation with the maximum legal tailwind allowed in sports, high-altitude air density to reduce drag, an optimized carbon fiber spike shoe, and the absolute limit of force a biological muscle can exert before tearing itself apart. The computer models reached a startling conclusion. Under mathematically flawless conditions, the absolute peak velocity a human being can physically reach before the body suffers catastrophic mechanical failure is roughly 31.5 miles per hour. Translated to the track, that means a perfect human could theoretically run the 100-meter dash in 9.3 seconds. That is the hard biological red line of Homo sapiens. When Usain Bolt ran 9.58 seconds in Berlin, he wasn't just racing against the athletes next to him. He was operating at roughly 97% of the absolute mathematical limit of our entire species. We may never outrun a house cat in a short sprint, and our biology will always keep us bound to the earth. But every time a human athlete shaves 1/100th of a second off a world record, they aren't just breaking a rule, they are waging a war against physics, anatomy, and millions of years of evolution. Thanks for watching. If you want to dive deeper into the hidden data and science behind the absolute thresholds of the human machine, make sure to hit that subscribe button.